But think about in your cloud environments, you are going to configure a policy, and the policy will have to apply to a virtual router. But now the problem is you don't know which virtual router to apply. You don't know which virtual network to apply. Because you are managing thousands of the tenants over there, hundreds or even tens of thousands of the virtual machines in virtual network over there, how do you know where to apply your policy? Okay? You don't know where is the correct place to apply the policy. In the previous lab, you did the lab, you configure a policy and apply to virtual network. But now you are simply too many virtual networks. We don't know where to apply. So we have a new way of implementing the security policy. The way is we give everything a tag. We give everything a tag. For example, you can say, oh, all the virtual machine with the Windows operating system, we give it a tag called WIN. All the Linux virtual machine, I give it a tag. The tag is Linux. All the network with the subnet 10.1.1.0, I give it a tag 10.1.1. So in the future, you are going to configure the policy not based on source destination, instead based on tag. I want to configure a policy. The policy is for any of the resource, any of the virtual machine with the tag Win, go to any of the virtual machine with the tag Linux. And if they passing through the virtual network with the tag of net, then I would like to inspect the traffic. If that is the TCP FTP traffic, I would like to block. Okay? So you don't have to worry about where to apply the policy. You just need to give it a tag. So that is a new way of configuration, configure your policy. So we call it policy framework. And in the control security configuration, based on your policy configuration, traditionally, just like we said, we have 3 different ways of configuring. Let me summarize that again. One is virtual network to virtual network, but the virtual network are the same. For example, this is left virtual network. This is also in the same virtual network. Then you configure security group. Second, if you would like to provide a security between the virtual network, but the virtual network are different. For example, this is left and another one is right. Then you configure network policy. 3, in the future, in the new version, there is coming up with a tag. So you can tag everything. For example, every VM has a tag equal to Win. So you can have so many virtual machine with the tag and go to another device with the tag of Linux. For example, you have so many virtual machines over there. And if they passing through the virtual network that has a virtual network tag, we call it left to right. So if you put the tag in here, put the tag in here, you tag to everything, then your policy will something like, in the future, I configure the policy for this tag to that tag, we passing through this tag, then I'm going to block. Okay, so you don't have to worry about the single device, how to inspect that in a single device. So that is a very new way of configuration. We call it policy framework again. So the policy framework will looks like this. You will tag everything. For example, HTTP protocol, we have a tag, we call it service. And web, we have a tag, we call it endpoint1. And we have a direction from left to right, we have a tag, we call it direction. So in the future, you just tag this. You just configure the policy with the tag. And this function will be available in Control 4.1 and after. Okay, so that's the concept. So just like I said, everything will come with the tag. So all you need to do is when you configure the virtual machine, when you configure the virtual network, when you configure anything, you will come with the tag. You just specify what is the tag label. And before you doing anything, the control will come with the predefined tags. So for example, predefined tag come with a tag. We put it application, tier, deployment, site, and then labels. You can put any name you want to that tag, and then assigning to the virtual machine or to the virtual network. Right? So how do we configure the tag? Here, go to the configure, and there is a tag, and go to the project scope tag. So again, project, which means tenant. Now, which means I would like to create tags for these tenants. And then under the correct tenants, you create a tag in here. So for example, you would like to have a tag which is belonging to application tag. So you can put the tag value in here. For example, my SQL server. Okay, you can put this. And then after that, you generate a single tag and then you save it. And after that, when you create an application, for example, you have an application, you can put a tag in here. So you can put a tag. Then the application you created in the future will follow in with the tag. And then you can use the tag as a component to configure your policy. Right. So this is how you create a policy. You go to configure, security, and the project scope policy, and you create the policy under the correct tenants. You select the firewall policy, you create one policy. Now this time you will say, okay, what is my policy name? First you create the policy name, and then go to the next page. Now you will see, all right, for any of the resource with the tag, which is web, to any of the destination with the tag, for example, application, and the direction is bidirectional. If they are passing through the TCP 443, I'm going to pass. All right, so you see, that's how you configure the policy. You not specify the source destination anymore. Instead, you specify the tag. And then you can apply the policy to anywhere you want. After you create a policy, the policy will become a set. So you can have an application policy set, and then you can monitor the policy in the control screen. For example, you go to the policy scope, a project scope policy, and then you click the application policy set. Then you can create a policy in here, or you can monitor existing policy from here. Control security for how to read it. How to read this? Kubernetes. But somebody read it, I don't know why. Kubernetes. I don't know which one is correct, but I heard about somebody read it Kubernetes. Should be Kubernetes, I know. Yeah, should be Kubernetes.
What did he call it?
They call it Kubernetes.
Kubernetes. Oh, yeah, right.
Somebody read it Kubernetes, but somebody read it Kubernetes. Okay? All right, no problem. And Kubernetes is a control security. So in control, we can use the Kubernetes security, which means you base on the label. So we just gave you the name, policy framework. There is another name for it. We call it Kubernetes policy. And the Kubernetes policy supported by control. However, control, before the control, Kubernetes by itself is a standalone product. But in control, we integrate that product into control. So become the control security. However, we changed the name a little bit. So you probably need to know, if you have already familiar with the Kubernetes, you must know that Kubernetes called it label, but in control, we changed the name to tag. In Kubernetes, we call it namespace. In control, we just keep it as the same, namespace. And network policy, we change it to firewall policy. Ingress rule. Ingress CIDR rules, we call it firewall rule or address group. And cluster, we change it to a name, we call it policy set. Okay, just a name mapping, you just good to note it. And then monitoring and visualization. After you configure it, you can have a look what the policy looks like and who has been applied to that policy. We can use the monitor. Now here is a use case. We have 3-tier application. We have some of the application belonging to web, some of the application belonging to application logic, some of the application belonging to database. And we have already configured the network policy to permit all the traffic and apply to all the virtual network. The firewall policy permitting the traffic from the web to the application logic and also permit the traffic from the application logic to the database. So as you can see, web to application logic to the database. So now in here, how do you know what are the server belonging to database? How do you know what are the server belonging to application logic or the web? You can monitor it. You can go to the monitor. You can select the security dashboard. And then you will see there are some bubbles over there. Each of the bubble belonging to a device. And then you can click one of the bubble and it will showing the detail of the bubble. So what is the traffic? Oh, the traffic is from which tier to which tier. This is web to application logic. Another is application logic to database. And how many traffic has been passed through. And there's another way to show you the traffic load. Since the policy is become very complex, so it uses another way of showing you. For example, if you have the web in here, you have the application logic in here, it will give you the traffic in this direction. And the traffic loading will be identified by different colors. If you would like to know the detail of the loading, you just click it and it will give you a window to show in here. So what's the traffic? And you can click it and go deep to see the traffic load. Again, the traffic group setting. You can take a look, the traffic group setting. The traffic is filtering what kind of the traffic by verify the configuration you have done. For example, what are the categories is belonging to application and deployment. And this policy will be applied for how long. Okay, you can also specify the time range to scheduling your policy. You can also go to one of the endpoint statistic to look at the device. For example, what virtual machine is receiving what kind of the traffic by using which policy. You can also match. You can also monitor the match the policy rule and the flow by go to one of the flow and you can select the policy and you can see, okay, the policy is generating the flow and what is the flow? It will give you the detailed information about it. Okay, now it's a very easy chapter without the lab, but I would like to summarize this. Can anybody tell me in Contrail there are 3 different ways of configuring the policy? I have repeated that again and again. What are the 3 different ways? 1, security group. 2nd, network policy. 3rd, tagging or policy framework. Okay, but in Contrail, we call it policy framework. Actually, we borrow the concept from. How do we read that?
Kubernetes.
Okay. Okay. Good. Thank you. Now let's come to the last chapter. Chapter 15, control installation. In this chapter, we are going to give you some information about how to install Control in case you want to build up a lab by yourself. So in this chapter, we are going to cover, we are going to explain the pre-installation task and the rules. Second, we are going to describe the server manager and the server manager lite. So what's the server manager? What's the server manager lite? Third, describe the control installation using server manager lite. And finally, we are going to give you some of the information about additional setting and operations. So pre-installation and the rules. In order to build up a lab, you would like to consume as less as resources as possible. So for the proof of concept or POC, you can configure only 3 servers for the lab. So minimum of 3 servers. And all the non-compute role can be configured in each control node, which means you have one server, a physical server, installed with the OpenStack and the control. OpenStack consists of project, and control consists of nodes. The nodes in here, again, 3 most important nodes, including config node, control node, and analytics node. That would be one server. And then you need at least 2 servers, additional 2 servers for compute node. Compute 1, compute 2. And then connect them together in the same something. That's it. That's how you do a lab. Somebody say, hey, can I install everything together in a single server? Yes, you can do that. But what's the point to do that? If you put everything in a single server, how you simulate the compute node build up the tunnel to another compute node? You won't be able to do that, right? So that's why you need to at least 2 compute nodes. You have to simulate how they build up the tunnel. And then each of the server need to have at least 256 gigabytes of RAM. I'm talking about RAM. I'm not talking about disk. And 500 gigabytes of disk. 16 CPU cores. Wow. You see?
Like Xeon processor.
Yeah. So if you are talking about Xeon processor, how many cores a Xeon processor can provide?
18.
18. Probably
Oh, no, there's another
some of the
28.
Xeon processors go to 24.
There's
No,
28.
Yeah, 28, okay. But in this case, you need at least a huge server, okay? You have probably 2 Xeon processors, each of Xeon processors at least 8 cores over there. And then you need to have 500 gigabytes of the disk, but it's minimum, And the memory, 250 gigabytes is huge.
It's huge. I don't think there's some servers support that. Like, not a lot of servers support it. 56 gig of RAM, that's huge.
Yes, that's huge.
My music computer's got 128 gig of RAM and 18 cores. Yeah, I know.
Server will support, George, but just laptop simulation.
No, but
will
yeah,
stop.
but that's good because a lot of operating systems aren't going to support more than 128 gig at the moment anyway. They say they do.
What's the biggest stick at the moment? How much gig frame?
128.
Just one stick?
Yeah.
One stick?
Yeah.
Maybe 256, no?
I haven't seen one. There might
I haven't seen 128.
So there's lots of 64s around just in the shops, but yeah.
Okay, so let me ask you a question. When you're doing the lab, each of you has 3 servers, right? In the lab, in our lab.
Yeah.
Each of you has 3 servers. Each of the server need to have this resource. So you have 5 in here. you know how valuable of the resource in the lab. Okay, it's huge. It's actually huge. Right, and then you need to get an installation software where you can download from Juniper. If you have the account, Juniper account, you can go to Juniper to download it for free. It's trial version. You just install it without install any license and you get the full feature. But there is no support. Okay, so you just download it. And then you need to, since you have to prepare 3 servers, and each of the servers need to install with the operating system. So what operating system we are talking about? The operating system can be Red Hat, CentOS, or Ubuntu. Okay, it can be anything. But we suggest that you use the Red Hat. Because Red Hat, actually, they are all Linux, but Red Hat providing more feature than the other operating system. And then for the orchestrator, which means in one of the server, you install the control, and also with the OpenStack. OpenStack is the orchestrator. Somebody say, I don't like OpenStack. Because in my enterprise, I have already a solution which is VMware. So can you replace this by using the vCenter?
Yes.
Yes. Okay. So orchestrator can be OpenStack, vCenter, or Kubernetes, or even the OpenShift. OpenShift is a version of the cloud stack, but it's not many people using it. Okay. And all of this software can be downloaded from Juniper, and they all come with an extension name of TGZ. All right. Now, if you install that, 3 servers need to be prepared. And each of the server need to come with a host name. One of the server containing the OpenStack and the control, we will just simply assign the host name as OpenStack. And in the OpenStack server containing not only the OpenStack, but also containing all other control nodes, including the control node, analytics node, and database until now. And you have 2 other servers, we call it control compute. And you just give it the name, compute 1 and compute 2. Okay, now we know how to prepare. What's the hardware software requirement? Now, the next step is how you install it. In order to let you install it easier, before I talk about that, I would like to talk about my son's case again. My son, his instructor asked him to install OpenStack. So my son just download everything from the open forum, okay? And then first, he installed the Linux. And then he installed this project, that project. Each project you need to install. And then he installed another server for the control. And he installed this node, that node. Each of the node you need to install separately. So finally, you know how long does it cost him to install the server? Almost 1 month. Almost 1 month. Almost 1 month, he finally finish up the installation. Because you know what? All the components, the version are related to each other. If you install one of the component with different version, then you will crash everything. You will have to start it from the start over again. So that's the problem. From Juniper point of view, we don't want our customer to do something like that. So we provide you a way to install it by using a server manager. Server manager, which means it's a server, okay? And you install a server manager in here, and then for you just pre-install the operating system, for example, the Linux, okay, for the basic installation in here. And then from the server manager say, oh, I would like to install the OpenStack. Then the OpenStack will push to the server, okay? All the project will push to the server. Control will push to the server. and compute node will push to all the server. So server manager will make your life easy. So that's one of the configuration. And the second one is you can use the Red Hat OpenStack platform director, which means you need to download it from Red Hat. It's provided by Red Hat. Third, you can manually install. I think I don't suggest you do that. Okay, if you want to spend 1 month to do it. I don't care. Okay, but that is not a good way to do it. And the last one is Fabric script. Fabric script no longer supported because in the old version we're providing you a script. You just run the script in each of the server. Then the script will help you install the necessary components step by step. Okay, but we no longer support the script. All right, now installation method for Kubernetes. If you would like to install the Contrail Kubernetes cluster, that will help you to provide the high availability. So Kubernetes is a component not only supporting the Contrail to provide the policy framework, but also supporting the Contrail to provide the redundancy. If you have two Contrail, you can redundant to each other. All right, now let's stepping back. There are so many ways to install. The easiest way for you is Server Manager. So let's focus on the Server Manager. In the Server Manager, by itself is a standalone server. You can use the Server Manager to install all your other server like the Compute Node or OpenStack or Contrail. You not only install, sometimes you can re-image. You can say, okay, I have already installed this server, but in the future, later on, I want to install an additional compute node. So you want to provision an additional server. Yes, it can be done. You can also use the Server Manager to reconfigure and monitor every server, whether they are up and running, whether they are in a healthy status from the Server Manager.
That also comes from Juniper?
Yes.
Server Manager?
Yes, it came from Juniper. So Juniper not only providing you the Contrail OpenStack, but also providing you this software, helps you to install it. And the way to manage, you can use the Server Manager by using the web UI. Okay? Or if you want to do the mass deployment, you can use the API. So the Server Manager also providing you the API. The API is the REST API. Or you can put the script into the Server Manager to tell the Server Manager, say, okay, based on the script, I need to install 10 servers, so do it for me. Okay, so you can create the Server Manager CLI script. And under the hood, there are so many software will be used together, like the Cobbler, Puppet, Ansible, Docker, and SQLite. But you don't have to worry about each of the components because they are all under the hood. Right, Server Manager by itself is a server. It also consuming the resource. Sometimes you say, oh, I don't want to do such complex thing. I only want to use the Server Manager to do the basic installation. So I'm not going to use all the function of the Server Manager. That'll be fine. Because you are doing the lab, if you want to install a Server Manager, you want to use probably 250 gigabytes memory again. So now you want to use a smaller Server Manager just to do the basic installation. Yes, we do have another version of the Server Manager. We call it Server Manager Lite. Right? So Server Manager Lite, also called SM Lite. And the same function except for a server operating installation. So you see, what's the biggest difference between the Server Manager and the Server Manager Lite? If you want to install a server, first you need to install the operating system. And then you probably on top of it install the Contrail. Server Manager will help you to use this server remotely push the operating system and also push the Contrail. But if you manually install the operating system first, you can use Server Manager Lite to push only the application on it, for example, Control. Okay, but this part you have to install it manually by yourself. The installation by using the Server Manager Lite. For example, you need to have a Server Manager Lite. And again, the Server Manager Lite is a software you can download it from Juniper. And then you put all other server in the same subnet. And then you pre-install the Linux operating system. And then you go back to the Server Manager in here by using the GUI. And you configure from the GUI, say, okay, I would like to push the application to here. So this server will become the OpenStack and control. I would like to push the virtual router in here. So this device will become the compute node. I would like to push virtual router to here. It will become another compute node, and that's it. Oh, by the way, the server manager started with the OpenStack version Okata. Remember the first day we talked about there are so many versions starting with the later, right? We have the Mikata, Okata, something like this. Installation stage, just like I said, for the server, you need to first install with the operating system by your own if you are using the Server Manager Lite. So what kind of the operating system we are talking about? Linux. And just like I said, the Linux, we recommended that you install the Red Hat. But in our lab, since we are not using the up-to-date version, so in our lab, we are using the Ubuntu. The Ubuntu with the version of 16.04.2. And after you finish up the operating system installation, you know that since if you're familiar with the Linux, every time you install the Linux, the new version Linux nowadays, after you finish up the Linux installation, there is a firewall. The firewall already there. But since you need to remotely push the application to the operating system, you need to first enable the SSH service. So the Server Manager Lite will be able to use the SSH connect to the server. But the default firewall rule doesn't allow you to do that. All right? So first, you install the operating system. Second, please go to the root account to disable that security. And then enable the SSH service in here, create an account. Let the Server Manager Lite use the SSH connect to each of the server. Then you will be able to push down the application.
How are you gonna push down the application?
You're
gonna push it down through what? FTP?
SSH.
SSH to remove to how are you gonna push file to be executed?
I don't know, you can use Portal, what do you mean?
I'm sorry?
Using SMLite as an application, you're gonna use an SSH connection, you're gonna do it.
SSH to remove to
Yeah, so that's the protocol that
well, he
you
said to push the OpenStack into one of the machines.
Okay.
So in order to push
First,
that,
first.
it's a file and then to be executed. Yeah.
First, you will connect to the operating system by using SSH. Second, before you do anything, the OpenStack application package is already there.
Oh.
You save the application in here, but it will be sending or push to here
Yes,
by
push.
using SSH.
You're gonna push a file using SSH.
Yes, yes. And then also will come with a script. And since you are logged in by using root account, you will remotely execute that script to run that package, and that becoming the installation.
You're gonna push the files over SSH.
probably about a million times.
And some of the basic configuration you need to be done first. For example, you need to configure the server manager to know which device with which IP address, and you need to resolve the host name. So in the etc host, you need to have a file. The file is smcloud sv edu junipernet. You can use the file to define which host with which host name with which IP address in here. And then you need to configure the LAN port of each of the server. Just let me stepping back. In here, for example, this server has an IP address of 172.25.11.4. That should be pre-configured, because if you doesn't configure that, then you won't be able to SSH to the device, right? Of course. Now we go to the file of each of the server to configure each of the server's interface, and you just go to that interface, make sure, okay, this is the interface name. Not necessarily the same like this, depending on the server. And then to just make sure each of the server has the correct IP address, and also make sure the DNS server can reachable, is reachable. And then you prepare the Contrail JSON file. I just mentioned about that the server manager lite will sending not only the package, but also a script, right? This is the script. This is the JSON script. You don't have to configure the JSON script by yourself, because the script, the template, is already in the server manager there. All you need to do is to verify whether the host name is correct. For example, you want to use the OpenStack, then yes, by default it's OpenStack. But sometimes you don't like the OpenStack as the host name. You want to call it the OpenStack 111. Then you change the OpenStack 111 here. You just change the file to match your need. And also, you verify the interface IP address and the MAC address. Because when we sending the package to that device by using the SSH, the server manager lite will make sure that device has the correct IP. Also, the MAC address is matched, because we want to have some kind of security to make sure the push destination, the target is correct. So the MAC address need to be specified in the script as well. Right? If you have more server, you just copy paste to the second portion. So we have the other server. Okay, you can copy paste to the third server. So you can copy paste as many as possible, depending on how many servers you want to install. All right, and then you now going to install the server manager package. It's to the server manager. A package, which means what? Which means the OpenStack, which means the Contrail, all the package you download it from Juniper. So if you download it from Juniper, you can install the package to the server manager lite. And the package will be saved in here and eventually sending to each of the correct server based on the script. Okay. And here are some of the commands that allows you to use the configuration for the container if you are using the container. By default, there is no container. You don't have to install the container. Container is only an option. Okay. And here is the script to configure which server will become a container. Okay, same as this. All right, and then after the installation, you can use the command line to verify whether the provision or the installation has succeeded. You go to the server manager, OPT Contrail server manager, and using a script. There is a predefined script. You just run it, and it will, from the server manager, to parse the status of the remote device and see whether all the package has successfully installed and showing the status in here. So you run the script in Server Manager Lite, and it will parse the status from the remote site. So now you see when you run this Server Manager script, this is SH script, and then it will from the Server Manager to parse the remote server status and sending back to your screen. Now you have already installed 3 servers, and this server has the IP address and the MAC address over there, and the installation has completed. Okay, nice and easy. And then you can run the Docker execute to verify the status. Now this command is that you go to the individual server. You have 3 servers, right? Go to the individual server to run the native command, and you can check whether their nodes or their projects are up and running. Some of the commands can also allowing you to do some more verification. For example, you can do the authentication locally in each of the server in here by use the admin operation RC SSH.
So this will be done only once in the organization, right? This whole installation.
One organization.
So that's right. All this is going to be done only once, right?
Yes, right. Only done in once. Okay. It can also be used if you want to provision more compute node. For example, now you have only installed 2 compute nodes, right? But you say, oh, in the future, 2 compute nodes is not enough for me to do the lab. I need the 3rd one. Yes, you can do that again, but only for 1 compute node. Yes. All right, and then if you go to the Server Manager Lite GUI, it did provide you a web UI, so you can log in to the Server Manager by accessing to the Server Manager Lite IP address with the port number 9080, and then you should be able to log in. After you log in, you will have a workspace like this, but don't be confused. Now you are in the GUI of the Server Manager Lite. You are not in the control, even though you look this, they looks like the same. But this screen is on the Server Manager Lite. If you look at here, you click the configure of the monitor, and you will see the I'm sorry, this is setting. If you configure the setting, you will see the options are different than the country. Then you can see that you can monitor the server, you can monitor what kind of the operating system is installed for that server, what kind of the package has been pushed down to that server. You can also make sure whether the control has provided by high availability. If you have only 1 control over there and you worry about the high availability, you can now add another server so they can clustering together, so you can more high availability function. Okay, here's the package. You can add the package and then put the package in here. So for the future, you can use the package to install more servers. Here are the server workspace. It's showing you that you have already installed 3 servers and all the installation has completed. If you want to add more, no problem. Let me stepping back. You just click add, and then it gives you a window. Then now, what's the additional server you want to call it? The host name is compute tree. And then you specify all the necessary information, for example, the IP address, then the components will be pushed down to the 3rd server. And then you can assign the role for that server. Oh, this server is going to play a role of the compute node. So you can select the control compute role as the role. And then you can also use the Server Manager Lite to provision a new server. Okay, you can add a new server in here. The Server Manager also give you the command line for you to verify each of the stage of the installation. The utility just called Server Manager. You can add, you can delete, you can display by using the command line. Exactly the same, just like you did from the web UI. Or you can use the API to do the same installation. The API, you need to use the CURL and browse to the IP address of the server manager. But the port number needs to be 9001. Following with the URI, and you insert the Python script to the API. So which means you need to pre-configure the Python by your own. Right? After the installation, now we can do some kind of the additional setting and operations. For example, you can change it to a newer version by upgrade the server. Currently, we are running the Control 4.0. Actually, nowadays, Control 5.0 is coming up. 5.0 providing more function. Maybe you want to upgrade. You can use the Server Manager Lite. You can use the API, you can use the GUI. Every way, you can upgrade the server in any of the way we just mentioned. If you would like to upgrade, there are a few steps you need to be careful. First, make a backup of the analytics database. Why? Because when you are doing the upgrade, normally if the upgrade is smoothly and successful, then nothing will lost. But just in case, okay, just in case if there is something wrong, the most valuable asset for you is the analytics database. So first of all, you need to back up that database. Second, if you want to upgrade from 4.0 to 4.1, you need to add a Control 4.1 image to the Server Manager first. Okay, so copy the Server Manager image. Copy the Control image to the Server Manager. I'm sorry. And then third, upgrade the cluster by provisioning the cluster with the new image if you have the cluster. If you don't have the cluster, you only have one server. There is no second server as a backup. You can skip this. And then four, monitor the progress. Okay, you can use the command in here to monitor the progress. Every time you run it, it will give you an information. Oh, it's still running, it's still running, it's still upgrading. If you run that again, finally it will give you the provisioning is completed. Then everything is done.
So upgrading control is complete downtime.
No, no downtime. If as long as you have the high availability cluster over there. Okay. If you don't have the cluster, then the answer will be yes. All right. Good. Thank you. All right. I think I just finished up the last chapter. Okay. Any question from here? All right. Thank you. Now I would like to ask you to do one more lab, if that is okay. All right. Please open your lab guide. And there is a lab installing Control. Please go through the lab, and the lab is quite short, only 13 pages. All right. As long as you finish the lab, that'll be all for the training. Thank you.
Thank you very much.